You'll be happy to know this is the last installment of our nomenclature videos. This is acid nomenclature, and I want to point out a couple things right off the top, and that's all previous nomenclature stays the same. So up on the screen behind me are the list of sort of big nomenclature things that we've done, also things that have a video for. In terms of the nomenclature and recognizing an acid, it's different sort of from how we would identify an acid in terms of its chemical properties. So what we do when we talk about acids and bases as chemical properties will be a little bit different than simply recognizing an acid as something we could name as an acid. But either way, you're going to notice that hydrogen will be the first element in the acid. Certain compounds are written differently because they're not acids, so we make sure that hydrogen is not. The exception, of course, is water. We put H2O, we put hydrogen first, but I don't think anybody's ever going to think that one could be an acid. The hydrogen actually will end up behaving as an ion, an H+. If we have not talked about acids and bases in terms of their chemistry, then that may be a new idea to you, but it comes back. By the way, it's always a +1, so we don't have to worry about Roman numerals or things like that. But if in the compound HCl, which we'll identify as an acid, we'll name as an acid, we could think of it as an ionic compound between H+ and Cl-. Same thing, and we'll end up with a charge balance. So SO3, sulfite, has a -2 charge, so that would take 2 ions of hydrogen. And if I had a PO4, phosphate, we need 3 hydrogens. By the way, at no point will you ever be asked to break it down into what I have in brackets. It's just I want you to see how we get those numbers. If you had something that's still an ion that has an H in it, it's possible that it could have some acidic properties, but we would not name it as an acid. And this is sort of the difference between what we do for nomenclature and how we recognize acids and bases in terms of their chemical properties. So the first 3 I could name as acids. The last one here, A, it's not a compound. B, I don't know what its properties are. I do, but that's not the issue here, but I would not name it as an acid. The other thing is, in that sort of shift of nomenclature, and as time goes on things change, this may not be the current official way of identifying, of doing acid nomenclature, but it's a very traditional and a very common method. So in the same way that we had when we talked about alchemist nomenclature, which still nobody really calls it that, it's very, very common. So in order for you to communicate with people about these kinds of compounds, knowing this kind of nomenclature is going to be very, very useful. So we're going to break it down in terms of the types of ions that we have. And some of our ions end in IDE, mostly the ones on the periodic table when they're the negative ions, so the non-metals. But there's a couple of, one in particular that's going to be an issue here, polyatomic ion that ends in IDE. Now, short version of how we do it is we call it hydro something ic, and the something, what I have identified here as the root name, that comes from basically from the name of the ion. So if I had HF, F is the fluoride ion, I would call it hydrofluoric. If I had HBr, that comes from bromide, and again, there would never be the expectation for you to put the bromide in brackets like that, but you would need to know that's the bromide ion, so then you would call it hydrobromic acid. And if you had HCN, it's from the polyatomic ion list, cyanide, hydrocyanic acid. Next kind of ion is our 8 ions, and these are all polyatomic ions, and it's actually kind of similar except we don't use the hydrogen, which sets us up into a potential problem, but we'll come to that in a few minutes. So with H2SO4 rather, it's using the sulfate ion. We call it sulfuric. Now if I can just pause here for a moment, you'll notice that we took a syllable and put it back in. So instead of having just sulfic acid, which doesn't sound right, we've called it sulfuric. It wouldn't be completely wrong to call it sulfic acid because you're doing the things you need to do. It's just that nobody calls it that. So the correct name, the proper name, is sulfuric acid, where we put that syllable back in. HBrO4, we're using the perbromate ion, so if I go to root name ic acid, it would be perbromic acid. And this one, if I have more hydrogens or H2C2O4, that's from the oxalate ion, oxalic acid. Third kind of ion we have, third kind of negative ending we have is the ite ions, ITE. Similar to the previous one, we don't have a hydro in front, we just have the root name and an OUS ending. So phosphite ion, as an acid loaded up with hydrogen, would be phosphorus acid, and much like sulfuric acid, I've brought an extra syllable back in, so instead of just phosphorus acid, doesn't sound very good, we've added the OR sound back in, phosphorus. Similar would be true for the sulfite, and on the previous example if I'd used phosphate. So just we'll deal with it in class if that doesn't make sense. HBrO comes from the hypobromus, so turning that into root name us, so I said hypobromus already, I was one step ahead of myself. Hypobromite becomes hypobromous acid. By the way, if you take a quick glance, hypo and hydro don't look crazy different from each other, so be careful that you're actually reading so that you're not looking at that thinking that it says hydrobromous, which wouldn't be correct anyway. And if I had H2S2O2, that's from the thiosulfite, then it would be called thiosulfurous, it's a mouthful, acid. Okay, a couple little final thoughts. This is where I usually click too far and end up with a big mess on my hands. In most of these acids, the hydrogen is not specifically indicated. Yes, it's true that for the ide ions it was hydrochloric, hydrobromic, but for all of those polyatomic ions it's not specifically labeled. So if you see sulfuric acid, phosphorus acid, you need to know what the ion is, but you also need to know that there's hydrogen there because it doesn't tell you in the name, unlike say hydroiodic acid. Oh, hydrogen. So you have to keep track of that. So for this one, I don't identify hydrogen as there. So if I didn't see the formula with the name, I just saw nitric acid, it's important that I know what that means, which goes back to our beginning, which is how do I recognize an acid? Hydrogen is the first thing. Hope this helps, and we'll try it in class.